Hello. This video will explain the combination of series and parallel circuit. Watch to the end, and through two examples, you will learn to calculate all the parameters that characterize the circuit. So let's go. In the first example, a mixed circuit with 3 resistors is presented. Resistor values and supply voltage are known, and all currents and voltages in the circuit must be calculated. First, we need to calculate the total resistance. From diagram A, we see that resistor R1 is in series with resistors R2 and R3. In node 1, current I is divided into current through resistor R2 and current through resistor R3. In node 2, these currents are reconnected, and this is a clear signal that this is a parallel connection of resistors R2 and R3. The total resistance of resistors R2 and R3 is calculated as follows, and the diagram can be simplified. Diagram B shows that we now have a classical series circuit consisting of resistors R1 and R2-3. We calculate the total resistance. Now that we know the total resistance, we can easily calculate the total current I. Now we take a step back. In fact, diagram D represents diagram B, but now we calculate the voltages on the resistors. This is extremely important to us when designing a voltage dividers or setting a static operating points of a transistors. We'll talk more about that in one of the following videos. And now we return to the initial diagram, denoted by E. Since we calculated the voltages V1 and V2-3, it remains to calculate the currents I2 and I3. For this calculation we use the voltage V2-3, which is common to resistors R2 and R3. Current I1 is in fact current I, and currents I2 and I3 are calculated as follows. With these results, we came to the end of the first part of the video. In the second part, we will deal with a much more complex example, so, if you like this video, please subscribe, like, comment, suggest, and expect many more interesting videos very often. Thanks for watching.